Welcome to lesson 10 of GMAT Math Basics. As always, if you don't need help with GMAT Math Basics, just head a little bit past in the feed to find more advanced topics. Today, we're going to answer an important question, which is how do you perform long division to get a result in decimal form rather than whole number remainder form? So we're going to talk about how to do long division with decimals specifically. Last time we stopped with whole number remainders, and sometimes the GMAT will ask for whole number remainders, so it's very important to know how to do that. But other times the exam might ask for decimals specifically, so you'll want to know what we're going to discuss today in addition to what we discussed in the previous lesson. There's a lot to learn or maybe relearn about the basics of long division. So I wanted to make sure that we didn't obscure those basics in the previous episode by adding more advanced material. But now that you hopefully understand the basics of long division, let's talk about how you can use long division to generate decimal values. Let's return to the example that we used in the previous lesson, 107 divided by 3. I'll briefly rehash the basic steps of this, and I'll invite you to do the same. So take a moment and ask yourself, how would you set up and perform long division on 107 divided by 3? Pause and see if you can recall the steps, or at least visualize as much of the process as possible. If you're able to write it down, then by all means, please take the time to write it from memory and test yourself. Hopefully, as a first step, you're thinking how to set this up visually. And we talked about this in the past. Again, I'll just briefly rehash it. You write a 3, then a vertical line right to the right of that number, and then you write 107 to the right of that vertical line, and then you will put a horizontal line above 107. So if you think about 107 divided by 3 as a fraction, 107 would be the numerator, 3 would be the denominator. And what we do with long division is we put that denominator to the left of a vertical line and the numerator to the right of that vertical line. Hopefully, you also remember the acronym DMSB, which stands for divide, multiply, subtract, bring down, which is the basic cycle of long division. Now, if we attempt to do this, 107 divided by 3, we can't divide 1, the first number in 107, by 3. So we write a 0 right above that one from 107. Now, if you're not familiar with how these basics work, definitely go back to the previous lesson before you proceed with this one so that you can refresh the basics of long division. Here, I'm going to gloss over those basics, assuming you have gone through the previous segment. So we cannot divide 1 by 3, so we write a 0 right above the 1 from 107, and then we multiply that 0 that we just got times the 3, which is the denominator, to get 0. 0 times 3 is 0. And then we write that result right below the 1 from 107. And then we subtract that 0 from 1, which yields 1. Then we bring down the 0 from 107 right to the right of that 1, and that creates 10. And then we just repeat our DMSB cycle. So we divide that 10 that we just got by the 3, that is the divisor, and we get a quotient of 3 with a little bit left over. We'll come back to that in a second. So we write that quotient of 3 right above the 0 from 107, and then we multiply that result times the denominator of 3. 3, the result, times the denominator of 3 yields 9, and we write that 9 at the bottom of the tens digit column, and then we subtract that 9 from the 10 that we got in the previous step by bringing down. So 10 minus 9 yields 1. And then we bring down 7 from 107 to make 17. So if you're not familiar with the DMSB piece and you feel like I'm moving a little fast here, you might want to repeat the previous lesson to make sure you're solid with those basics. Now we just DMSB again. So we divide that 17 that we just got by 3, the denominator. The result is 5 plus a little bit extra. We write that 5 right above the 7 from 107 in the units digit of the result, which is above the 7 from 107, right above that horizontal line we drew. And then we multiply that 5 times 3, the divisor, or what I'm calling the denominator here, to get 15. And we write that 15 right below the 17 that we got from the previous cycle. That's dividing and multiplying. Now we subtract 17 minus 15 leaves us with 2 as a result. And then there's nothing else to bring down. And this is kind of where we left off with the previous lesson, because that's how we get whole number remainders when we're doing long division. But what if you want to turn that remainder into a decimal? Well, we actually already talked about some ways that you can do that using fractions and mixed numbers in a past lesson. But what I want to dive into here is how we can adjust the DMSB cycle to get a decimal result instead of that whole number result, because sometimes it's easier, more valuable, and or just more convenient to generate the decimals directly with long division. So the key stopping point here is that there's nothing more to bring down, and that's what stops the DMSB cycle. So what we're going to do is we are going to add a decimal point to the right of both the numerator and the result. So we've got 107 in the numerator spot, and we're just going to put a decimal point right to the right of 7 there. And then we will also do that directly above it in the result area, which so far in 107 divided by 3 is 0.35. That's what's in the result area right above the horizontal line above 107. So we're just going to put a decimal point right to the right of the 5 from 0.35. So those two decimal points should be right above one another or below one another, I guess, depending on your orientation. They should be vertically stacked. Let's put it that way. What we'll do then is we're going to write a 0 right to the right of the decimal point in the numerator. So right to the right of 107, and then we've got our decimal point right to the right of 7. We're going to put a 0 right to the right of that decimal point. This works because we're not actually changing the value of the numerator when we do that. 107.0 has exactly the same value as 107. Same with 107.00 or 107.00000. You get the idea. Why do that? Well, it allows us to bring down that 0 to the right of the decimal point and keep the DMSB cycle going. So let's talk about how that's going to play out. If you think back to our most recent step, we had a 2 at the bottom of our result, but then we had nothing to bring down, so we just stopped. But if we add that 0 to the right of the numerator with the decimal point, now all of a sudden we can bring that 0 down to make 20. And again, that allows us to now do the DMSB cycle again. So we've got 20. We divide that by the original denominator 3 to get a quotient of 6. 3 goes into 26 times with a little bit left over. What we then do is we write that result of 6 right above the number we just brought down, which is exactly what we would do if we were just doing normal long division. But in this case, that 6 is going to go right to the right of the decimal point that we wrote in the result area. So now in our result area, we have 0.35.6 in the result area. And that's the first step to being able to generate decimal values using long division. It's a very useful skill. We can also repeat the rest of the cycle. So we can take that result of 6, multiply it by 3, the original denominator, to get 18, and then write that at the bottom of our work, so right below 20. We can then subtract that 18 from that 20 to get 2, and then we go through that one more time. We write an extra 0 to the right of the numerator. So in the numerator piece now, we would have 107.00 written there. And then we just bring that 0 down right to the right of 2 that we just got from subtracting to make 20 again. And then we just DMSB again. Now at this point, you might suspect the exact same thing that we just did is going to happen again. And you would be right, because previously we brought down a 0, which made 20, which we then divided by 6, which we then divided by 3 to get 6, which we then multiplied by 3 to get 18, which we then subtracted from 20 to get 2, and then we brought down another 0 to make 20. So if you're guessing that we're going to get another 6 in the result to the right of the decimal and end up with 35.66 up there, then you're absolutely right. And what happens if we do that again? Well, we're just going to get the same thing. And this is what happens when you have a repeating decimal as part of your result, which coincidentally 107 divided by 3 does generate. The actual result of 107 divided by 33, excuse me, the result of 107 divided by 3 is 35 and 2/3, which if we express that as a decimal is 35.6 with that 6 after the decimal repeating forever. So theoretically, we could do this cycle of long division, DMS being forever, to keep generating sixes to the right. Obviously, we don't want to do that on the exam. It's just a demonstration of the technique. But if a question asks us the value of 107 divided by 3, perhaps obviously it's unlikely that would be the entire problem on the exam, but it's very likely that it could be a step in a problem. And if it asked us for the answer in decimal form, then it would be really helpful to know that it is 35.66666666 repeating forever. So that's the basics of generating decimal results using the DMSB cycle of long division. Let's try one more example so that this really sinks in. Let's do 205 divided by 4. Ask yourself, do you recall all the steps, or at least the general concepts that we'll use here? Take a moment and test yourself. We're doing 205 divided by 4. See if you can visualize how that would play out. It might be a little much to try to do the actual math in your head if you are only on audio right now and you're in motion. If you're on audio and you've got a paper and pen or pencil right in front of you, then that's fantastic. Hopefully you can pause the episode and try to run this one on your own and see if you can figure it out. But if you're listening just on audio, see if you can just recall the concepts. So what happens if I get a whole number remainder and I run out of things to bring down? What would I do? See if you can remember that for yourself right now. Let's go through it together. So first, we set it up visually by writing a 4 and then a vertical line right to the right of 4 and then 205 right to the right of that vertical line. Then we draw a horizontal line right above the 205. Then we just DMSB, divide, multiply, subtract, bring down. So we divide 2 by 4. However, we cannot do that. So we write a 0 above the 2 from 205, and then we multiply that result times the denominator, which is 4 to get 0. We write that 0 below the 2 from 205, and then we subtract the S from DMSB. We subtract 0 from 2 to get 2, and then we bring down the B from DMSB. We bring down the 0 from 205. We write that to the right of the 2 we just generated, and then we have 20 down there. And then we just DMSB again. So we divide 20 by 4, the original denominator, and that equals 5. And we just write that at the top of the column we just brought down from. So in this case, we write 5 above the 0 from 205. Then we multiply. We multiply the 5 we just got times 4, the divisor, and that equals 20. So we write that below the 20 we got previously, and then we subtract 20 minus 20 equals 0. Then we bring down the 5 from 205, and we write that right to the right of 0, which means the value is just 5. Then we DMSB again, divide 5 by 4, which is the original denominator, to get the quotient of 1, and then a little bit left over. And we write that quotient of 1 above the 5 from 205 in the result area. Then we multiply that result of 1 times 4, the original denominator, which yields 4. And we write that right below the 5 from the previous cycle. We subtract that 4 from 5, which yields 1. And then we write that at the bottom of the column right below the 5 and 4 we just subtracted. Then there's nothing to bring down. So if we wanted the whole number remainder, when dividing 205 by 4, we would know that that whole number remainder is 1. But if we want a decimal value, then we simply write a decimal point right to the right of the numerator, so 205, and then a decimal point right to the right of the 5. And then we write a 0 right to the right of that decimal point, and we write a decimal point right above the decimal point in the result area as well. So in our numerator, we have 205.0. And right above that, we've got 51 and then a decimal point right to the right of that. So we have a 5 right above the 0 from 205. We've got a 1 right above the 5 from 205. And then we've got a decimal point right above the decimal point from 205, decimal point 0. Then all we do is bring down the 0 that we just put to the right of 205. And we write that right to the right of the 1 that we got in the previous subtraction. And that creates 10, which again allows us to do the DMSB cycle. So let's divide. 10 divided by 4 yields 2 with a little bit left over. And we write that quotient of 2 at the top of the column we just brought down from. So we write the 2 right above the 0 that we just wrote to the right of the decimal point from 205.0. So right now in the result area, we've got 51.2 or 51, then a decimal point, and then the 2 we just generated. So we multiply that 2 that we just wrote times 4, the original denominator, to get 8, and we write that at the bottom of the column we are working in, right below the 10 that we got in the previous cycle. Then we subtract. 10 minus 8 yields 2. And generally, we want to continue this cycle until there's no remainder, so we'll keep going in this situation. Or, relevant to the previous example, we want to continue it until we realize that the result is just going to repeat forever. But we don't have that clarity. At least I wouldn't have that clarity at this point in this process. So I'm going to continue. I'm going to add another 0 to the right of the numerator to make it 205.00. I'm going to bring that 0 down and write it to the right of the 2 we just got by subtracting, and we make that 20. Then we divide that 20 by 4, which is 5 exactly. We write that 5 right above the column that we just brought down from. So in the result area, we now have 51.25. We multiply that 5 that we just wrote there at the end times 4, the denominator, which yields 20. And we write that 20 below the 20 that we generated in the previous cycle, and we subtract to get 0. And at that point, if you subtract and get 0, and there's nothing else that you need to bring down without adding additional zeros to the right of the numerator, then you are done. So let me just repeat that. If you get a remainder of 0 in a long division problem and there's nothing more to bring down, that is the time to stop doing long division. Now, just to explore the theory here, if you kept going with this pattern and added another 0 and brought that down, then you can imagine this, or see it if you're doing on paper, that you will keep cycling through DMSB, just adding more and more zeros to the right of the numerator and to the right of the result. So let's talk through that real quick. Because we got 0 in the last subtraction, if we add 0 to the right of 205 to make it 205.000 and then bring that down, the denominator of 4 will go into 0, which we just brought down. Now it's just 2 zeros right next to each other at the bottom of our work. 4 goes into 000 times. We write that to the right of the result, 51.250, and then we multiply that 0 we just got by 4, the original divisor, to get 0. We put that 0 below the 00, then we subtract again, and we get another 0, and we just repeat that cycle on and on and on and on and on. So much better use of time, almost certainly, to just stop and move on with our lives, so to speak. So that's it. That is pretty much everything you would need to know to generate decimal results using long division. Sometimes that is the best strategy for the situation. It's definitely the case on some GMAT problems. So again, very valuable skill. So I want to pause there because as we transition into talking about decimal operations, which we will in the following lessons, I personally believe that those are better taught in a little bit more segmented way versus just tacking it on to the skill that we just built just now. But I'm looking forward to sharing more about dividing by decimals, multiplying by decimals, adding decimals, and subtracting decimals. Also very, very, very useful skills. And I look forward to discussing that with all of you very soon. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the GMAT, please head to our website, thegmatstrategy.com, which is linked in the description of this content. And check out our video presentation on how to achieve your dream GMAT score in half the normal time. In the meantime, this is a weekly show, so please subscribe and please stay positive and stay consistent with your studies. I'll talk to you all soon.